On the left side, when we take x squared minus 2x plus 1, we're going to factor that. So we need factors of 1. They're going to add to 2. So factors of 1 that add to 2 are 1 and 1. They both take the first sign, which in this case is negative. And you'll notice that you end up with a, 2 factors that are identical, which is the whole point, because the next line we're going to write that as x minus 1 quantity squared. And notice that's now in the correct form. Let's do the same thing with the y coordinates. So factors of 4 that add to 4, that's going to give me a y and a y. Factors of 4 that add to 4 are 2 and 2. And we'll put minus on both of those. So we end up with x minus 1 quantity squared plus y minus 2 quantity squared is equal to 9. And now it's in standard form. So now we can come in and graph it, find the center and the radius, and then graph it. So let's walk through that whole thing again just to make sure everybody's got it. So we started off with something that's in general form. We separated the variables, kept everything that was x's and y's on the left side. We moved the constant on the right side, and we grouped x's together and grouped y's together. We then completed the square. We took half of 2 and then squared it. We took half of 4 and squared it. And when we added to both sides. We then factored it, which gives us our standard form. Now, I'm not quite done yet with this, so I want to erase, I guess, my steps. So, and then here's where I'm going to write what we started with, x minus 1 squared plus y minus 2 squared equals 9. Okay, so I have both the general form and the standard form of the equation that we're working with. Okay, so where's our center? In order to graph that thing, the center is going to be at
1, 2.
Beautiful. And what's our radius?
3.
Yeah. So 1, 2, and 2 is up here, and then we'll go out 3. So 3 to the right, 3 to the left, up 3, and down 3. And there's your circle. Okay, now I noticed that because we're using the online homework, we're going to have to follow their directions, and they also want us to find the x and y intercepts. And these are not going to be nice values, and I can't pull them off my picture at all either. So we want to find the intercepts. I'll be honest that if I do this as a face-to-face, I don't make them find the intercepts because it doesn't add a lot to that picture. I can draw the picture without those intercepts. So, but because we use the online, I can't take off part of the homework. So let's go find the intercepts. So we have 2 different forms here. We have this beautiful, or really ugly actually, general form, and then we have our standard form. So in order to find the x-intercept, what do we do again? To find the x-intercept, we let
Y equals 0.
Y equals 0. Okay, so which form is it easiest to let y equals 0 in? Well, you can do it in this original general form, but this means this is a 0, this is 0. You then have an x squared and a 2x. I think it's a lot easier to let it equal 0 in the standard form. So that's what we're going to do. So we would have x minus 1 quantity squared plus, and now in place of the y, we'll put a 0, minus 2 quantity squared is equal to 9. So that's x minus 1 squared plus, well, 0 minus 2 is a -2, but when I square it, I'm going to get 4 equal to 9. And now we need to solve this for x. So again, I'm going to try and take the most efficient route. I'm going to move the 4 to the other side. That'll give us x minus 1 quantity squared is equal to 5. And then we'll square root both sides. So I'm going to avoid foiling if at all possible because I just have to factor it when I'm done. So that's going to give me x minus 1 equals plus or minus the square root of 5. So then your x-intercepts are 1 plus or minus the square root of 5. And that's the x-intercept. That doesn't help draw this picture at all, but there are 2 of them. There's one here, and we just found them. Again, I prefer to write them as 1 plus or minus root 5, comma 0. I noticed that when you guys took the quiz over the weekend that my lab math does not like it written like this. They just want this. So I did go back in and give full credit for those of you that wrote them in the correct format. So I went back in and checked it. But yeah, it was looking for just this as the intercepts. So drives me crazy, I tell you. Okay, now we gotta go find the y-intercepts. So I'll leave my x-intercept sitting right there if I can. Okay, to get the y-intercept, we'll do the same thing. We're gonna come in and replace the x with 0. So when I do that, I'll have a 0 minus 1 squared and a y minus 2 squared equals 9. So a negative 1 squared is 1. And we'll go ahead and move the 1 over. That's going to give us y minus 2 squared equals 8. And then we'll square root both sides. So same kind of process again. So y minus 2 is equal to plus or minus the square root of 8. When I move the 2 over, I'll get 2 plus or minus the square root of 8. You can simplify 8. 8 is 4 times 2, and I can take the square root of the 4. So I end up with 2 plus or minus 2 root 2. And again, that's ugly. I mean, in order to plot that, I'd have to take it to a decimal in order to be able to plot it. But I have 2 of them. Here's one of them, and here's the other one of them. So we now know the y-intercepts. So the y-intercepts are at 0, 2 plus or minus 2 root 2. It is good practice at finding intercepts. So I think that's why the author does it. Okay, so there's all the information that we need for that problem. We completed the square in order to put it into the correct form, our general form, and then our standard form, sorry. And then we found the center and radius. We were able to graph it, and then we found our intercepts. So they're kind of long problems. You guys have 3 of them where they're in this general form in order to be able to do it. So that's where you'll spend most of your time. Okay, do you want to do another one where we're completing the square, or do you think you have it?
On that one, is order of operation what take? Because I could see myself tripping up, subtracting the 2 and then getting root 6. So does order of operation, you square the 8 first?
Yeah. Yeah, so we had, what was it, 1 plus y minus 2 quantity squared equal to 9. So you have to follow the order of operations. You're isolating the y, and to isolate the y, you're going to isolate the square first. So we'll have the y minus 2 squared equal 8. And because of that exponent, it's trapping that y on the inside, which is why you have to square root before you can do anything else. So,
right.
Yeah.
Okay.
Yeah. Yeah, math is all about the correct order of operations, boy.
Right.
Yeah. Okay, do you want to do another one where we complete the square and not necessarily do everything else? I'm a little worried because that's the only time we've ever completed the square. We'll need it again when we graph parabolas in chapter 4. So it does come back to haunt us a little bit. Let's do one more. We won't do everything about it, but I'd like to complete the square one more time. So let's say we have x squared plus y squared plus 6x plus 4y minus 3 is equal to 0. All right, that's really sloppy. That's a 4y. So x squared plus y squared plus 6x plus 4y minus 3 is equal to 0. Now what I want to do is just find the center and the radius. So okay, so what we're going to do is group like variables together. So we're going to keep the x squared and the 6x together. Next, we'll write the y squared and the positive 4y, and we'll move the 3 to the other side. So when I move the 3, it's going to become a positive 3. Okay, now we'll come in and complete the square. So we have x squared plus 6x plus. Okay, so now we're going to do the completing of the square. Half of 6. So what's half of 6? And then we're going to square that. So 3 squared is 9.
Yes.
Okay, now we'll keep going. We're going to do the same thing for the y's. So we'll take half of 4. Half of 4 is
2.
squared.
4.
Yep. So we'll add 4. Okay. Now on the other side, we have to add the same quantities. So we added a 9, so we'll say plus 9. And we added a 4, so we'll say plus 4. Okay, and again, I don't really look at the sign on the when I'm taking the half because I know I'm going to square it, and when I square it, it's automatically a positive. So that's why I tend to ignore the signs. Okay, on the right side, that's the easy part. 3 plus 9 plus 4 is 16. That worked out well. Okay, on the left side, we need to factor those first 3 terms. So factors of 9 that add to 6. So factors of 9 that are going to add to 6. So factors of 9 that add to 6 are what? 3 and 3. And they should be identical. You're trying to create that instead of parentheses squared. So sure enough, that gives me x plus 3 quantity squared. I know it's a plus because that first sign right there is a plus. They're both going to take that sign. Okay, what about in terms of the y's? So I need factors of 4 that add to 4. So factors of 4 that add to 4 are 2 and 2. Which is going to give me my y plus 2 quantity squared equal to 16. So now we have it in standard form, from general to standard form. So where is the center for this particular circle?
-3, -2.
Beautiful. And what's our radius?
4.
Yep. Fantastic, and there it is. And again, this would not come out to be nice x-intercepts on this guy, right? If this y is 0, that would give me 2 squared, which is 4. I'd have to move that over, then square root. It's good practice for you guys. So once you've done a bunch of those, where you start off with the equation and find the information, you're going to do what I call the go backward questions. So they're going to give you information about the graph and ask you to write the equation. So let's try one of, well, I've got 3 of those I want to do. Okay, so what we want to do is we want to write this standard form. So the directions are going to say, find the standard form of the equation in the circle. Okay, so our first example, we know that the center, this is what we're given, is at 1, 0, and it contains the point -3, 2. So it contains a point, and I've got the center. So I think that in order to understand what they're asking, it helps to kind of draw a picture. So we know that the center of our circle is at 1, 0. So here's 1, 0. That is the center. And I know it goes through the point -3, 2. So over here is -3, 2. And the circle is coming in and doing this kind of thing. So that's what I've got. I've got a whole circle. I've got a whole circle, but I know it goes through this point. So in order to write the equation of the circle, we know we need the center and the radius. So to write the equation, we need that center and the radius. Okay, well, they gave us the center. That's the easy part, but they did not give me the radius. So how can I find the radius of this circle? Would this distance right here be the radius? So can't I use the distance formula? And that's why we need the distance formula. So we're going to use the distance formula to find the radius. So, and again, what we're doing is finding the distance between the 2 points that are given. So the distance between the center and this point that's on the outside of it. So D is equal to, and again, that was x2 minus x1. So x2 is 1 minus that minus 3, plus y2, which is 0, minus y1, which is 2, quantity squared. And again, it doesn't matter in which order you do the 2 points as long as you're consistent. So the 1 and the 0 that are written first belong to the same point. The -3 and the 2 belong to the same point. Now we just have to clean that up. So 1 minus a minus 3 is 1 plus 3, which is 4, which we're going to square. 0 minus 2 is a -2, which we're going to square. Okay, 4 squared is 16. -2 squared is 4. That's going to end up with the square root of 20. Now, normally I would try and clean up that radical, but in this case, I'm not going to. This is now my radius. Okay, now we can write this equation of circle. And again, don't forget what we're going for is that x minus h quantity squared plus y minus k quantity squared is equal to r squared. So for us, we'll have x minus, and the x coordinate of the center was a 1, quantity squared. Y minus the y coordinate of the center is a 0, which I don't really have to write, but I don't want to lose anybody. And that's equal to the radius squared. So I'm going to write the square root of 20, and then we're going to have to square it. Okay, we do like you to clean that up a little bit. You don't need to FOIL or anything, but clean up any glaring simple things. So for us, our final answer is x minus 1 squared plus y squared is equal to, and square root of 20 squared is just 20. And that's our final answer. And there's the standard form for the equation of the circle that has a center at 1, 0 and contains the point -3, 2. So they gave me kind of the picture and asked me to write the equation. Any comments or questions about that? I think this is the easier way to go with these. That was certainly all over the board. Yay! Okay, 2 more. They're just going to get a little bit different on the information they give us. Okay, so the next one, same directions. We want to write the standard form of the equation of the circle that has the center at the point -3, 1, and is tangent to the y-axis. So our center this time is at -3, 1, and it's tangent to the y-axis. So in this case, tangent means that it touches in one spot. So this is telling me that it touches the y-axis in one spot, only in one spot. So if you think about a circle, it could cross the y-axis a couple spots. It could not touch the y-axis at all. This is telling me that it's actually going to touch the y-axis in a single spot. I, again, am going to draw out a picture of what they're telling me just to get a handle on what's going on. So this time we're over here at -3, 1. And because it says it's touching or is tangent in one spot, I'm going to go directly over and recognize that that's where I'm going to touch that y-axis, because anything else I try and draw for my circle is going to cross it in 2 spots or not cross it at all. So it's going to touch that y-axis in that one spot directly over. Horizontally over would be the way to say that. Okay, why is that so important? Well, if this is the center over here at -3, 1, and I'm touching the y-axis over here, isn't that distance right there the radius? And do I even need the distance formula this time, or can I literally just count it? Can't we see that we are 3 units away? So our radius is 3. I literally am just counting it over. So it's a very quick problem if I can recognize that. So the radius is 3. In other words, this is the point 0, 1, and we've gone over 3. And now we can write our equation. So then our answer is simply going to be x minus a -3. That's going to make that a +3 squared. Y minus the 1 squared is equal to the radius squared, and 3 squared is 9. So in that case, if you understand what they're saying in terms of the picture, you can just write your answer. my favorite kind of problem. Not a lot of work involved. Any comments or questions on that one?
Okay.
Okay, one more. This is as ugly as they can get. And it's not very ugly. So this time what they're going to tell me is that the endpoints of the diameter are at 4,3 and then 0,1. So the endpoints of the diameter, does everybody remember what the diameter of a circle is? That's the distance all the way across, going through the center. Again, I'm going to plot them just so I can get a handle on what's going on. So I have 1, 2, 3, 4, 1, 2, 3. So that was 4,3. And then I have 0,1, which is right here. Okay, so these guys are on either end of the diameter, and the circle is doing something like this. Well, we said a few minutes ago that in order to write the equation of a circle, we needed two pieces of information. I need a center and I need a radius, and they didn't give me either one of them. So is there some way to find the center of this circle? Have we got a suggestion on what we could use?
Midpoint.
Yep, beautiful. We're going to use the midpoint. So thank you. That was fantastic. So the center's at the midpoint. Good thing we have a midpoint formula. So that is x1 plus x2. So it's going to be 4 plus 0 divided by 2. And then it's y1 plus y2. So that would be 3 plus 1 divided by 2. So 4 plus 0 is 4 over 2. 3 plus 1 is also 4 over 2. So we're going to get the center is at 2, 2. So that works out really nice. Okay, so that gave me the center. So right now, we know we've got an x minus 2 and a y minus 2. But now we need the radius. Okay, so the radius is the distance between that center and either of the endpoints. So radius. And I'm going to use the distance between 2, 2, and I'll use the 0, 1 only because it's easier to work with. You could use the 4, 3, it doesn't really matter. So our radius is going to be that distance, which is, I'll do 0 minus 2 quantity squared plus 1 minus 2 quantity squared. So I took the x minus the x, so that's 0 minus 2. And then the y minus the y, 1 minus 2. Okay, so that's going to give us the square root of 0 minus 2 is a negative 2, which we'll have to square in a minute. And 1 minus 2 is a negative 1, which again we'll square. So that negative 2 squared is going to give us a 4. The negative 1 squared is going to give me a 1. And I end up with the radius of the square root of 5. There's no point in cleaning that up because you're going to take it from there and plug it into that standard form. So again, so the answer then, so we're after that x minus h squared plus y minus k squared equals r squared. So that would be x minus 2 quantity squared plus y minus 2 quantity squared. And that's equal to our radius squared. Well, the square root of 5 squared is just going to give me a 5. And there's our final answer to the question. So that one worked out really, really nice. And it was nice because you guys recognized we needed that midpoint. So that's the important part about this one. Okay, any comments or questions about the circles?
No, good.
Good? Everybody good? Okay, just as a final comment, I did grade the R1 review to date 1 that you guys emailed to me if you did it. And I have now emailed back your graded work along with the answer key to it, so you can take a look and see if you missed anything, what you missed. But overall, they were really nice. You guys did good. Okay, any other comments that you need to make? Any questions that you have for me?
I'm okay.
Okay.
No, good.
Okay. Again, later today, I'll email out the lecture notes for tomorrow because they're all word problems again, but I'll do that later today. So just check this evening or tomorrow morning before class so you have the problems yourself. And have a great day. Enjoy it. We're back up into the 80s again, so I'm going to go walk the dogs before it gets too hot out there. So, have a good one.
You too.
You too.
Bye-bye.
Good one. Bye.